So this is the plan I gave for our Monday section 2 weeks ago. Correct the old assignments. So I did the correction with them. I'm going to show you the answers and probably discuss them with you. So if you have your assignment, please put it with you in front of you so you can communicate with me the answers you have. And I took a lot of time to decide when to start data analysis part 2. And to be honest, I did not start data analysis part 2 yet. I don't know what to do. We don't need it for the first 2 experiments, but eventually we're going to take some time to do it. I will decide about this later because every session is being so long that I'm not finding room for extra data analysis. Usually we give it 1 extra week. However, in your case, I don't see on our calendar extra weeks, you know, we're very short on time. And then eventually we need to discuss projectile motion theory and experiments, okay? I'm gonna start by the assignment. Let me see where the answers for assignment number 1. Okay, so the first slide, significant figures, no need to go over it. I suppose you know the answers, unless you want me to. Let me keep the chats close to us in case someone, okay. All right, for the people who are on 3G, if you can afford that, good. If not, and you want to leave, this session it's gonna be recorded. You can watch it later and you can ask questions anywhere you want, okay? And ask for extra meetings if you want. So it's up to you to decide for that. Now, to continue with the measurements, probably I can ask, let me check on your names and move this to the side. I'm gonna start with Roy. Okay, so Roy, do you agree with this? The first ruler, this is a ruler that is not a regular ruler, okay? And one of the students gave me this answer. Do you agree or not? Roy is not here, probably.
I'm here.
Yes, yes, Roy.
Just checking, I forget because.
Okay. So do you agree or not?
We work on subdivisions. The smaller subdivision is 0.5, I think.
Yes, I totally agree.
Okay, so, but we don't divide by 2, so we let it as 0.5.
However, this is an analog measuring tool, so we must divide by 2.
Oh, we must divide it by 2, so it's 0.125.
Okay.
Or 0.025.
So the smallest subdivision is 0.5 centimeters. Half of it is 0.25 centimeters. Yes. We know that uncertainty must be rounded to 1 sig fig, right? So the 0.25 has been rounded to 0.2. So probably your answer was different, Roy, right? You have no idea. It was 2 weeks ago. You can't remember.
I put 0.25.
Okay, you kept it as 0.25.
I submitted a week ago. I don't recall the answers.
I totally feel you. I totally feel you. It's normal. Okay, so you remember that probably you left it as 0.25. Be careful. All uncertainties must be 1 significant figure. This is the reason why we did the rounding. And the 4.3 is good to keep since I have 1 decimal here and 1 decimal here, okay?
Okay.
Thank you, Roy. I can see that we have 2 different Roys. I should be careful with naming you. All right, Omar, probably talk to Omar.
Yes.
Omar, do you agree with this answer? Do you have something similar or different?
No, similar.
All right, do you have the same unit? Because I did not see the unit on 1 week ago.
I put kilogram.
Yeah, me too. I did the same mistake. However, one of the students saw that it was LB, which is pounds. All right, stay with me, Omar. What was your answer for this example?
0.5.
The uncertainty to be 0.5 and the actual measurement 33.0 or 33?
33.
Okay, so do you agree that your answer is wrong and you need to add a 0 because they should have the same number of decimals?
Yes.
Okay. A lot of students are asking why 0.2 and not 0.3. So every time you have a 5, how do we round? 5 is like in the middle. It's not 6 and above. It's not 4 and below. So statistics people decided to find a rule which is 50% you round up and 50% you don't round up. And it's a conventional rule. In other words, there's no rationale behind this rule. It's just conventional. It's a decision they took. All right. So I totally understand if you don't like the rule. The rule states that if you have an even number to keep, you keep it. If it's odd, you round up. So 0.25 will be 0.2, but 0.35 will be 0.4, just to have it even. Now, in your case, if you don't like this rule, you can do 0.3. I totally know that probably you will not, like, it's really not possible for you to have this question. Probably you'll never ever face this issue, you know? So let's not make a big deal out of it. If you want to know the rule, it's the odd even rule. You want to follow it? Let's do it. If you find it very frustrating, just ignore it, okay? Fine. So this is slide number 2. If you have questions, please let me know. The next slide is this one. And let me tell you that we did not agree at all for these values. Probably I can ask Maria. Maria, do you have any answer?
Yes, I did the mean, but I forgot to do the error on the mean.
Okay, and what was the mean, your answer to the mean?
The mean was 38.0.
You decided to round it to 1 decimal, right? Why?
Yes, because we're summing up the values and they all have 1 decimal.
Yes, I heard this with other students. And everybody asked why and how come this should be 3 significant figures. Like if we add those and divide by 6, the answer should be 3 significant figures, or actually 1 decimal because we're adding. You need to be aware of something, and I'm not talking only to Maria, to everyone. Why do we do averages? The purpose is to increase precision, right? So under no condition your answer would be as precise as the values. Usually it's more precise than the values, unless the scattering you have is huge. Let's say you do those measurements over and over and over again, and we call them trial 1, trial 2, trial 3, and you end up with values scattered around the mean or very far away from each other, and therefore you will deduce that your setup or your measuring tool is not precise at all. This is where you say the average is less precise than my values. But you cannot say it's equally precise. It's usually more precise. And how do you know? Is by finding the uncertainty, the alpha RMS. The alpha RMS will study the standard deviation, and the standard deviation is proportional to how much scattering you have, you know? So if the values are not scattered, they are very close to the mean, standard deviation is the deviation, it's gonna be very small, and therefore alpha very small, and therefore more decimals involved and more decimals for the average. You see? So if I were you, Maria, I don't round the average. I find the error first, then I round the average. Anybody did the average, the error? Let me check the users on a different platform because I cannot scroll through the names and I don't want to be stuck with the same students. Probably talk to Dalal. Dalal, did you find the error? Or Carl or Romy or Emilio, anyone? Did you calculate the error on the temperature? Do you have an answer?
Yes.
Yes.
It's the same as in the slide.
Okay, so 0.07, this is what you got. All right, so we got this with the other classes, and like section 1 agreed, section 2 agreed as well, and your friend is agreeing as well. So the error is 0.07. Make sure the error is 1 significant figure, so round it to 1 significant figure. Then check 2 decimals, 2 decimals, fix your average to 2 decimals, okay? And don't forget to add the unit, obviously. So any question on this one? Let's move to the next. The question was to find R, and believe me, we did not agree on R. One section gave me 158.42. The other section gave me something else. Where is it? Here. This app is not nice. I can use another app. Okay. Another section gave me 159.84. Obviously, this one was the right answer. How did we do R? We simply did U over I, and we converted I from milliamperes to amperes by dividing by 1000. So I would